Here we go with section 2.3 part 1, which is called the algebra of functions. The first thing we're going to look at actually is talking about finding the domain from a question in the past couple days. We found the domain from sets of points, we found the domain from graphs, and now we're going to say, okay, if I have an equation, what's the domain of that equation? And so right now we're just going to focus on two types of equations, and if you have your notes page, you need to fill in equations with fractions and equations without. Those are the words that I'm using from that first sentence, and then you can tell from the rest of it what's missing on your notes page. So you have equations with fractions and equations without. Equations without fractions, the way you find the domain is that without fractions, it's simply going to be that the domain is all real numbers. Equations with fractions, it doesn't matter what we have as a fraction. It doesn't matter what else is there with the fraction. We take the bottom of our fraction and set it equal to 0 and solve. And that makes our domain all real numbers except for that number. And the reason is that if we have a fraction like this, 5 over x, we're saying what number, if I put it in the bottom, gives me a 0 on the bottom, because in this case it'd be 0. If I put a 0 on the bottom here and I'm dividing by 0, that's not allowed. That doesn't work. And there's one reason to think of it is when we divide, we're saying, and we have like 5 on top here, we're saying that we're trying to divide like 5 people into 0 groups. That's what division normally is. Like, we have this much and we're trying to divide it into this many groups. So how do you divide 5 people into 0 groups? You don't. And just like that, you don't divide by 0. Like, it doesn't work. So let's do a couple of examples. On this first one, part A, you want to look at this and say, is there or is there not a fraction in it? In A, there is not a fraction, which makes the domain be all real numbers. That's if we spell it out in words. We talked about interval notation with our graphs yesterday. All real numbers in interval notation is negative infinity, comma, positive infinity. So that's part A. So anything that doesn't have a fraction, you automatically know that this is the domain, all real numbers. Part B, we have a fraction. We want to take the bottom of that fraction, which is x minus 6, set it equal to 0, and then solve. Okay, and what we're saying for our domain, we're going to say our domain is all real numbers except x cannot equal 6. Because what we're saying here is that I can plug in any number I want to in for this x. Any number I want, except for 6. 6 is the only number that doesn't work. We cannot plug in a 6 here, and that's what this domain is saying. That we can plug in any number we want to, except x cannot equal 6. The way to write that in interval notation is kind of tricky, and so that's why I gave you this format to write it in. But just in case you need to know, we would say, well, we can go from negative infinity until we get to 6, and then we would go from 6 to infinity, and both of the times that we write 6, we have brackets. I mean, not brackets. We have parentheses to say, hey, this is not equal to at 6. So this is negative infinity, comma 6, 6, comma infinity, and what that does is that excludes only the number 6 from our interval. So that's why I like what I have written in green better than what I have written in purple. The other type of problem seems really unrelated, but it'll be more related to what we're doing tomorrow. And so in your notes, you have there on the side f plus g of x, and I'll need a little bit of room, and I don't know what I was writing there. and then f plus g of 5. This question asks us for two things. It asks us to find f plus g of x, and then it asks us to find f plus g of 5. And so this is the biggest hang up here is probably the notation at first, because f plus g of x is not saying f plus g and then multiply by x. This is the same thing as saying, like, whenever we're talking about f of x, okay, and what we do is we plug in whatever is in right here, we plug that in for x. That's what this is saying. So what it's telling us to do is simply add our two functions together. Here is f, and here is g, and we're going to add those together, and that's what f plus g of x is. So 5x squared plus 2x minus 1 is f, 3x plus 5 is g, and since it's f plus g, we're going to add those together, which means any like terms we have, we need to add together. So like 2x and 3x. First off, we have 5x squared with no like terms. 2x plus 3x gives us 5x. Negative 1 plus 5 gives us 4. And so this right here is f plus g of x. Because this is an x here, we'll end up with x's in our answer. So that's one way to check and make sure you actually did what it asked you to. We're not multiplying anything by x. X is in our answer. Then it asks us to find f plus g of 5 right here. Well, since we already know that f plus g is this, what we can do is simply put this 5 everywhere that x is. Okay, so remember order of operations. We have to square before we multiply. Exponents come before multiplication. So 5 times 25 is 125. 5 times 5 is 25, plus 4 gives us 154. And that's it.